the last two sections on independence and conditional probabilities dealt with probabilities for and. In other words, the probability that I get this thing and this thing, right? Two different things together. Now we're going to be looking at the probability of this or that, okay? So or is the probabilities we'll be looking for now. But first we have to deal with how plain English doesn't necessarily match up with what we want in math, where plain English is actually sometimes unclear. So if somebody, right, asks me whether I've taken any chemistry or physics, I've actually taken both, I would answer yes, right? Like, yeah, I've taken that. So there, the question is really, have you taken any chemistry or physics or both, right? That would actually still count as a yes. I would answer yes to that. Let me give you a different situation, right? So suppose I go over to somebody's house and, it's in the morning and they ask me, would you like any coffee or tea? I'm not supposed to say, yes, I want both, right? They were offering me coffee or tea, right? Like one or the other. I don't get to pick both. And if somebody came over to my house and they said both, I'd pour them in the same cup just to be as ridiculous as they are with that ridiculous answer, okay? When somebody asks you that, they mean one or the other. If you get a wedding invitation and there's like fish or beef, like you don't get to check both. You pick fish or beef, right? You don't get to do both. Sometimes things are like that, where it's an exclusive or is what that's called. We need to figure out in math which one we actually mean and stick with that. And in logic and mathematics, or is always going to be that inclusive or, where it can be this thing or that thing or both. Okay? Both would still count. If I'm looking for the probability that it's sunny or cold, then I'm looking at sunny days, just sunny, cold days, just cold, and sunny and cold days, right? All of that would count. So just be aware of that as we go through these probabilities, that it doesn't have to be one or the other. It's this one, or both, right? All of that counts when I'm looking at this. Okay, so we're going to have a formula for all of that, but I just wanted to make sure we understood what that inclusive means as we're going through these probabilities. And I'm not going to be really using that word inclusive because it's already implied in logic and math. So let's look at these probabilities. This would be this formula that I have right here. So I'm looking for the probability that I get one event or the other. I should be thinking about adding, right? When we were doing and probabilities, we were multiplying, okay? So there's kind of a common theme with that. What I multiplied was different, whether I had dependent or independent events. But here I want to be thinking about adding. And yes, there's some subtraction here. I'm going to get to that in just a second. So this is our kind of base formula for that. And what I'm doing is essentially just saying, okay, I'm just going to consider these events individually, which is usually easier to think about, right? And I'm going to add up those probabilities of the individual events occurring, and then I'm going to subtract off the probability that they both occur. All right, so let me talk about this. So suppose we're looking at sunny and cold days, right? The probability of being sunny or cold. Now, if I added up the probability of being sunny with the probability of being cold, right, that would just be the number of days that are sunny out of 365 plus the number of days that are cold out of 365. But what about the days that were sunny and cold? I've counted them twice here. I've counted them in the days that are sunny, and then I added them together, right? If I go back to this formula, I've added them together with the ones that are cold. So I've included those days twice, the days that are sunny and cold. I've included them in the probability of being sunny, and I've included the probability of being cold. I don't want to double count them. And so that's essentially what this piece right here is doing, is subtracting off what I've double counted. All right, so that's how that formula works. In the next video, I'll show you how to work with that just directly as a formula.